This podcast is presented by HANNOVER MESSE, your leading event for industrial AI.
Hello everybody and welcome to a new episode of our Industrial AI podcast. My name is Robert Weber and my guest today is Dr. Fabian Bause. Welcome, Fabian.
Hi, Robert.
Before we start, Fabian, please introduce yourself briefly to our listeners.
Yeah, sure. Yeah, my name is Fabian Bause. I work at Beckhoff Automation as a product manager. And at Beckhoff, I'm responsible for mainly everything around machine learning or AI.
Okay. Fabian, let's take a quick look back. You were at our AI in the Forest event last year. Our topic then was AutoML with Professor Dr. Frank Hutter. And after the event, you sent me an email and you sent me figures from a data science report. And then you had one quote. And the quote underlines the thesis that AutoML is not the accelerator at all. And I thought, okay, I don't need to ask Fabian about AutoML anymore. And yet we are sitting here because you are introducing an AutoML tool by Beckhoff. Why is that?
That's a good question. So maybe first of all, so I said it's not an accelerator. What I meant with that sentence is I think it's an enabler. So it's, of course, by a certain extent also an accelerator, but at the very first, it's an enabler for domain experts, for those who don't know how to create an AI model. So to my understanding, the benefit from automated machine learning is enable domain experts, machine building engineers, automation engineers to create AI models without the need of understanding the complete complexity behind machine learning. So basically what AutoML does is automating a data scientist.
Mm-hmm. But why you are now presenting or launching an AutoML tool?
Yeah, that's a good question. So basically, we started 2019 with inference engines for our TwinCAT PLC software.
We had an episode on that, yeah?
Yes, we had an episode on the podcast on that, at that time in German language. And so this inference engine was focusing on tabular data and directly inferencing in the PLC. And that was a huge jump for Beckhoff and also for customers. And now, 2024, we, of course, extended this portfolio a lot. So now we can not only inference, let's say, classical machine learning models or multi-layer perceptrons, but also more complex deep learning models that allow for processing of image data, so for vision data. And on top of it, we also extended our hardware portfolio. So we not only can inference on CPUs directly on the industrial PC, but also on the GPU. And still, it's completely inbuilt in our PLC environment. On top, we also have now cameras, a camera portfolio. So we evolved a lot into also a full stack vision company in terms of hardware and software. And so time is now ready to bring out something new. So we have all this stuff ready for the shop floor that you can assemble everything and run AI on our IPCs in the PLC. Mm-hmm. But somewhere the model has to come from.
Yeah, sure.
That's the bit that we now want to focus on with our automated machine learning tool.
And you mentioned vision, you mentioned your camera portfolio. Do you focus then on vision use cases with the first step of your AutoML tool?
Yes, exactly. So the first step is exactly vision. So we focus on anomaly detection on images, on image classification. That's the first step. And then plan is to extend this later this year or beginning next year with object detection and segmentation tasks on images, but then also proceed to time series data, because time series is, let's say, the natural data that every PLC speaks.
the holy grail of machine learning in an industrial environment, I would say.
Exactly, yeah.
You mentioned enabling. Is it enabling the domain, the guys at the machine, or is it acceleration or inspiration or documentation? How does this tool will help the people at the machine?
Yeah, that's basically everything at once.
Okay.
So we are focusing on different types of target groups. So the first target group is, of course, the domain expert who does not necessarily has the skills of an AI expert. So the domain expert doesn't know how to pre-process the data, how to choose the right AI model, how to train it, how to hypertune parameters. So that's all automated. So this is the enabler part. So we enable the domain expert to create AI models without having the knowledge how to exactly train a model. So basically it's you upload the data. Let's say you have some folder structure. In one folder, you have images of your products that are good. So this is the OK class, and another folder with a not OK class. You upload this. So you have a labeled data set, so to speak. And the only thing the domain expert has to do is basically click on the train button. And then the magic is happening in the background.
Now you should tell us what is in the background.
Well, basically the background is like we have...
It's open source AutoML tool.
No, it's not. So it's...
But there are a lot of AutoML tools out there. Why is yours so special?
Ours is special because it's platform aware. So as we are delivering also the hardware and software stack for where the model should run in the end, the customer or the user can choose this model that I have needs to run on this and that Beckhoff IPC with this hardware specification and with this software version, and then can also choose a latency limit. So in automation, everybody speaks about time slices. So the process often defines in what amount of time you need to have a decision. And so we enable our user to set on this hardware, on this software, I need to run this model in, let's say, 100 milliseconds or 50 milliseconds. And this is a set of data you can use for training. And then we train a model that on the one hand fulfills the task itself, but under the constraint that on this target device, the execution time will not exceed these 50 or 100 milliseconds. So this is basically our approach that we brought into this AutoML.
How do you integrate now your tool? Is it an own software or is it a part of TwinCat? How do you integrate it?
Yeah, the integration is, let's say, loosely. So basically, it's one of the first times where Beckhoff offers a product that not necessarily has to be used by a Beckhoff customer, a machine building customer, because the interface is you upload data, and once you have a model, you can download an open readable ONNX file.
Okay. Can you quickly share what is ONNX? Maybe 2 sentences?
Yeah, ONNX is Open Neural Network Exchange, and it's a standard description of a trained AI model, so to speak. So basically, it's a standard. Every AI framework can export and import ONNX. Every inference engine, more or less, can import ONNX. So it's basically an interoperability standard. Yeah, so this is, let's say, the interface. It's completely independent from TwinCat. So data in, ONNX out. But so we have touch points, of course, with TwinCat. So in this configuration where you can select, hey, I want to run this on this Beckhoff IPC, on this TwinCat or library version. Also, where you bring in the data, we currently work on an own labeling tool based on the TwinCat Analytics Data Scout, which is already an existing product for data inspection. And so we extend this tool that you can label the data there and then upload it directly. So that's the touch point in that direction. On the export direction, besides the pure Onyx model that describes the generated AI model, we also export a PLC open XML file that also includes then the complete AI pipeline, so to speak. So the pre-processing and post-processing.
So do you build the pipeline for the customer?
Yeah, we create a pipeline. So we not only export the AI model itself, but also PLC code for pre-processing the images, then executing the AI model, and optionally also post-processing. And this complete pipeline is readable PLC code. And again, underlines the openness. It's a standardized programming language. It's the IEC 61131. So we use structured text. So it's and standardized programming language in a standardized PLC file format. So the PLC open XML file format is also open, readable. So this is really the idea, to keep it as open as possible.
Let's go to the shop floor. What does it mean to the customer? What do they need to do upfront when they now want to use your AutoML tool?
Basically, first of all, customers would need to create a clean data set for training. So, for instance, use a camera. So equip your TwinCAT machine with a camera. And with our standard TwinCAT Vision portfolio, you can already trigger in the PLC the acquisition of images, and you can also write those images to a file source. And then someone has to sit down right now to manually label the images. If it comes to, let's say, image classification, for anomaly detection, not necessary. So this is for now, but like I said, in the future, we will have a labeling tool also available. But nevertheless, so there are also open source tools or commercial tools for labeling available. So it's not a big deal to also use those software packages, label them, and then go to our platform. So basically, that's step one. Create a data set, a labeled data set. Then go to our platform, load the data on the platform, select the target device. So I want to run my AI model on a C6043 with this software, and then click train. So then you have a model.
How do I deploy the model now on my PLC?
Basically, you just download. There's a download button. You get the Onyx file and the PLC open XML. And then you open up TwinCAT Engineering again. You just go to the TwinCAT PLC, right-click, and say import PLC open POU, and then you have the PLC code integrated in your program.
Okay, that sounds very easy.
Yeah, so that's the approach. Keep it as much as easy as possible.
Yeah, sure. But can you describe a little bit your target group? Do you talk to mid-size machine building companies? Is it a customer pain? Or who is your target group?
The main target group is, of course, the broad machine building customer base of mid-size, let's say mid-size companies, because there we find lots of interest and also applications for AI, especially also in vision applications. But we also find a lack of AI experts in those companies. And so this is the main target group for the domain experts. But interestingly, after the AI in the Forest event, I also identified the larger companies with AI experts also as a possible target group, because then we come back to this acceleration factor. So nowadays, machine learning or creating a machine learning model is manual work. So maybe if you create multiple machine learning models over the year, you may have some sort of templates already, and okay, if I have this and that type of data structure, I would use this template, adopt it a little bit. But it's manual work and it's time consuming. So I had an interesting talk with Professor Huber from Stuttgart. He referenced a study where machine learning experts were asked to use an AutoML tool, and they just observed how they use it. And it's interesting because machine learning experts are focusing then on, let's say they use it as a baseline approach. So they use AutoML to generate a first version, a first baseline, and then they feel challenged and try to beat the AutoML tool, or they try to enhance the capabilities of the model that the AutoML tool exported.
But for a vision approach, I think this is not necessary because vision is done with all the models you can use. Or am I wrong?
Well, I wouldn't say that we can tackle 100% of all use cases that may appear. So there might be still edge cases where an AI expert could do better. But it's not only a question of the technology. Is AutoML able to tackle all use cases? But it's also a question about, let's say, the human feelings. So there is now a tool that can automatically generate an AI model. And of course, as an AI expert, I feel challenged. But with our platform approach, we also provide the AI experts, to my understanding, all the degrees of freedoms that they would need, because we export an ONNX file. So they can download the ONNX file, they can load it into their PyTorch or TensorFlow environment and do whatever they like with this model. They can fine-tune it, they can change it, they can use their explainable AI tools on it to investigate the behavior. So I feel this is also a very nice tool because of the openness even for AI experts.
Okay. You mentioned AI in the forest. We were at Aarburg at the time, and they have their own control system. What do I do if I don't have a Beckhoff control system? What then?
First answer, contact your Beckhoff sales representative and change that. Second answer is...
We will cut this out.
Now, basically, you have the ONNX file.
Yeah.
So you can inspect the PLC Open XML file, and there you can have a look on what pre-processing steps we applied before we go into the model. So basically, you can just translate by hand the PLC code into, for example, Python code, do the pre-processing steps, and use, let's say, for instance, the ONNX runtime to load the ONNX and execute it. So it's completely up to the user. So there is no need to run this exported model in TwinCAT.
But this is a new approach by Beckhoff, right?
Is it really? So basically, Beckhoff always followed the philosophy of open automation. So we always try to keep all interfaces as open as possible. So have a look on EtherCAT.
But now you sell a software, an app or an AutoML tool.
Yeah, that exactly bit is really new. Yeah, but I think it's necessary here. So it's the first time we want to sell a decoupled, so to speak, software that stands for its own. But as I described, we also have lots of interfaces to keep it seamless if you use TwinCAT.
Where do you see the limitations of AutoML?
Yeah, one of the largest limitations right now I see in the ability to automatically build AI models when it comes to time series data. And that's why we just don't focus on time series right now. We have it on our roadmap, but that also has been a topic at Aarburg on the AI in the Forest workshop, that also in the science, there is still not so much awareness of the need for AutoML on time series data. But maybe we changed that during the workshop. So that's, I think, one of the major challenges now for the next years.
AutoML has been around for a long time, and we see a lot of AutoML tools around for a long time, and we see a lot of open source tools. Why is now the right time?
Yeah, the right time for us is because we have, on the one hand, all the the work done for the control level. So we have the PCs, we are equipped with GPUs, we have the software to run everything. And on the other hand, the time is right for an own AutoML tool, because if you open up your Python environment and just use an open source AutoML tool, you still face several challenges. One of the challenges is most of our customers are not familiar with a Python environment at all. So the first question would be, so what is Python? How do I install it? And what is the right package? And so they are completely in another domain. And so the interface, so we create a nice visual front end where you just click and that's it. So that's the first thing.
But do they accept that? Because it's all about how accurate is the model, and do the domain expert accept the result? What about that?
That's a good point. We didn't speak about that. So after generating a model on the platform, so we of course present the model behavior, so to speak. So statistical metrics like, so what is the accuracy, what is the recall, what is the F1 score, and also, for instance, the confusion metrics that okay, in 1% of the cases, I would classify a good product as a bad product, or vice versa. So that's the statistical approach. And to bring more insights to the user, we also use another visualization. This visualization is like an explainer, or like a human being would explain to another one why on this image this product would be not okay. So basically we have the image and overlay a heat map. And this heat map highlights areas of high importance that resulted in this classification. For instance, that's not okay. And that's exactly how a human would say, have a look here in this area. Here I see a crack, and that's why I say this is not okay. So our approach is to not only provide to users a black box that creates black boxes, but also something like a transparency mode after the AI model generation.
You always test new applications, new tools with customers. What do they say?
Well, so we already tested this platform with some customers. And so basically the feedback is great.
Of course, is the feedback great?
Yes. So the very first feedback is always overwhelming. Hey, that's cool. I just have to click and I get a model. So that's the first feedback. And then if we proceed the project, the customers realize, okay, it's now easy to create the model itself, but now the expert knowledge is in the data set. So then they realize, okay, now I really have to take care about the data set itself. So what is a good data set? That's one of the major questions then we discuss. So sometimes I have one customer in mind who then asks, hey, how many images do you need for a good model? Is one image per class okay? I said, no, we need more. The next question was, is 3 then okay? And that's kind of the overwhelming, hey, this is a really cool thing.
But you need to do something for that.
But still you have to do something. So it's not automating everything. So what is AutoML now doing? It's automating the AI expert tasks, the coding stuff, how to generate the AI model. But still what you have to do is to show the platform samples, annotated samples, and the model will learn from those samples. If you input bad samples, your model will not work like you want it to be. So that's still the responsibility of the users to create a good sample base, basically.
What are your next steps with your platform or with your AutoML tool?
Well, first step is now to show it on HANNOVER MESSE this year. I welcome everybody on our booth to have a look around. And then the next step is to have more testers for our tool. So I invite everybody who has a good idea, maybe already a good data set, to contact me, because this is really challenging in industry to, especially now in this, let's say, closed beta phase where we currently are to get good data sets, industrial data sets. So you get lots of artificial data sets or non-industrial data sets where we can test our tool. But the real data sets and the data sets of real machine builders, these are the most interesting ones to test if
and more than 3, please.
more than 3 images, yeah. So it's really, it depends on the application, how many images we really need. So I can't really say I need 10 or 20 per class or 100 per class. It really depends. And so now the next step, we need more customers who want to work with our platform. And then during this year, or let's say late this year, we want to transfer to an open beta phase. Yeah. And then, like I said, so next year we want to tackle the
time series.
Yeah, time series and also object detection and segmentation for images.
We wish you all the best, you and your team. Thank you, Fabian. It was a pleasure. Greetings to Ferl.
Thank you, Robert, for having me.